This lesson will show you how to solve a non-standard maximum problem. This maximum problem is non-standard because the first inequality among the constraints, x1 plus x2 greater than or equal to 3, is not a standard inequality for a maximum problem. In order for the problem to be a standard maximum problem, all of the inequalities must be less than or equal non-negative numbers. Because x1 plus x2 is greater than or equal to 3, what we're going to do is introduce a variable called a surplus variable, and we're going to subtract that variable from the left side of the inequality to make it equal to 3. So x1 plus x2 minus s1 will equal 3. S1 again is called a surplus variable. Since the other two inequalities among the constraints are of the less than or equal type, we will proceed as we have done for the standard maximum case. The other inequalities are of the less than or equal, and so we add a slack variable, S2, to the second inequality, and a slack variable, S3, to the third inequality to make them equal to 2. The last equation, the z equation, appears as it did before. There's the initial simplex table for that system of equations. Keep in mind x1, x2, s1, s2, and s3 all must be greater than or equal to 0. That is very important. You will see where that comes into play when we pivot. Let's read the solution from this initial simplex table. x1 is 0, x2 is 0, but s1 is a negative 3. We will now pivot differently in order to get s1 to be greater than or equal to 0. First, we will determine the pivot row and then the pivot column. The pivot row is the row responsible for s1 equaling a negative 3. We see s1 equals negative 3 from the first row, and so the first row is the pivot row. We now look at ratios. Starting in the first column of row 1, we take the ratio of the number in the last column, 3, divided by the number in column 1, and that's 1. 3 divided by 1 is a positive ratio. As soon as you get a positive ratio, the number in that column can be the pivot. So the x1 column will be the pivot column. You're getting a positive ratio, 3 divided by 1, when you pivot on the number 1 in the first row, first column. And that's fine. This procedure for determining the pivot is going to be called phase 1. So the number 1 in the first row, first column is now the pivot. Reading the solution from this matrix, we see that x1 is 3, x2 is 0, s1 is 0, s2 is 5, s3 is a negative 1. The row responsible for S3 being a negative 1 is the third row. So the third row is the pivot row. Taking ratios, number in last column divided by the number in the x1 column would give me negative 1 divided by 0, looking at the third row now. That's undefined. Going to the second column, the ratio would now be negative 1 divided by a negative 1. That's a positive ratio, and so the negative 1 in the x2 column will be the pivot. So the pivot row is the third row, the pivot column is the second column, the pivot is that number negative 1. The solution now is x1 is 2, x2 is 1, s1 is 0, s2 is 3, and s3 is 0. All the x and s variables are now greater than or equal to 0. It is now that we apply the past procedure for determining the pivot, the procedure for standard maximum problems. And that we call phase 2. We are now in phase 2 for determining the pivot. And so the pivot column will be the third column. And since there's only one positive ratio, the pivot row is the second row. Because there are no negative numbers in the bottom row under the x and s columns, we are finished. We have reached the maximum z. The solution to the given maximum problem is the maximum z equals 30. This occurs when x1 is 2 and x2 is 4. You should see that from the final table above.